Hi everybody. Now I'm aware that I'm not going to be there on Tuesday because I'll be in Brussels working on the new syllabus, and there's something I think you need to be aware of, and it comes with differentiation and integration. If you need more questions than this, please just ask me. This is arc length. I'll first show you visually what this is, and then I'll explain how to answer a question like this in a test. Please share this with everybody. So imagine we have a coordinate axis system. And in an exam, always draw your graph. So let's say I had something, a function like this. If I wanted to work out, say this point here was at A and this point here was at B, the arc length is defined as the point from A to the point of B, so that line there. So this is called this is L, or the arc length. The formula is always given to you, and that is arc length is equal to the integral between A and B, the square root of 1 plus f dash of x, and then we need to square that, and that's integrated with respect to dx. Now remember that this is what we call the derivative, so the derivative. So how would we do a question based on something like that? Well, be careful to read the question carefully because it might give us everything that we need to know. So let's try and say if we had a function. So let's say if we had the function something like, so that curve that we had could be part of a negative quadratic. So let's just say that that is going to be the same as 6 plus 5x minus, let's make that a bit neater, 6 plus 5x minus 3x squared. So the derivative of this is 5 minus 6x. We need to know what A and B are. Let's say that A is given to us as 1, and maybe these are given to us, or you maybe have to find them as intersection points. If they're given to us, great. And A, let's say it's B, that is 8. So this is a calculator question. Now if this is a calculator question, which it is, I still want to see a little bit of working. So A is 1, B is 8, and that's the square root of 1 plus the derivative, which is 5 minus 6x squared with dx. That's enough. Now use your calculator. Now even because the chances are you're going to get a function that's much more challenging than a quadratic, maybe it'll have like an exponentials in or something like that. So what I suggest you do is you define, what do I mean by define the function? When I say define the function, I mean on the calculator you'd be doing something like this, and then you would define your function as, what did I call it, 6 plus 5x minus 3x squared. It might have an equals there actually. Let's just check. I'm just doing it on the calculator now. f1 of x, yeah, of course it has the equals in there, so let me just correct that for you. And I put that in as 6 plus 5x minus 3x squared. We'll enter, so that's now defined as a function. I just double check by putting f1 and it's in bold. That's great. Now I'm going to put everything in the calculator, find where the integral sign is. So it's what we call a definite integral between. Now the key word you're looking for is you can use your calculator, so we don't have to show too much working. So I'm just typing this into my calculator exactly as it is, and I want you to do this as well. I'm putting in the derivative of and I can even put the derivative of f1. So it's d over dx f1 of x. And remember, this is being squared, and we're differentiating, so we're integrating this with respect to x. And it's a horrific answer, so you do Control Enter, and I get myself 100. Whoops, let's do the correct color. We get 154.3 to 4 significant figures, and the units for this is not, it's not a area, so it's just a length, so we just say units. So you get the formula, you're given it, and you just have to apply it and make sure you round it as the question states.